This image shows an opening in the Temple of the 10 Niches in Ollantaytambo. Here, we see everything that makes such polygonal masonry so captivating. There are unique technical aspects. All the blocks are irregularly shaped and fit together with extreme precision. There is also a distinctive aesthetic. The exposed surfaces of the stones are smoothed and slightly protrude. Here, the protrusion is not very pronounced. But in other masonry structures, this feature can be much more noticeable. This appearance of the stone surfaces is a characteristic feature of polygonal masonry in South America. It resembles risen dough, creating the impression that the material somehow expanded or swelled. This is often interpreted as undeniable evidence that, at the time of placement, the blocks were in a plastic or amorphous state, soft and malleable. If that were the case, it would easily explain how they could fit together so precisely, sometimes even in rather complex interlocking patterns. A plastic state of the material would have naturally allowed for a perfect fit of blocks with curvilinear surfaces. And this is the most attractive aspect of both the concrete and plasticine theories. Many of these masonry structures are incredibly complex, and it seems almost impossible to achieve such results through mechanical fitting, especially using primitive tools. Supporters of the concrete theory propose several possible ways polygonal masonry could have been made. Volcanic ash-based concretes, classical lime-based concretes, Roman concrete, utilization of natural rock outcrops where the material was in a softened state. Meanwhile, proponents of the plasticine theory suggest melting the stone, radiation creep, as proposed by Sergei Pershin, thick consistency concrete, which does not require formwork, possible use of unknown, so-called extraterrestrial technologies, the existence of a plant-based sap supposedly capable of softening the surface layer of stone. The following arguments are presented as evidence. The already mentioned precise fitting of blocks, whose sides have complex curvilinear profiles. There are images of polygonal blocks with various textured surface patterns. These are interpreted as traces of mats, woven formwork, or imprints of wooden plank formwork. Some blocks contain inclusions resembling crushed stone and concrete. Certain surface artifacts are interpreted as pressure marks from upper blocks on lower ones, or as material overflow onto the lower blocks. These arguments remain rather superficial. Along with them, there are sometimes even comical moments when ordinary inclusions and natural structural changes are presented as signs of different stages of material softening. At times, there are also irreconcilable contradictions. In the first episode of the film Traces of Alien Technologies, various scenarios were considered where a block blank fills a certain volume while in a plastic state. If a block undergoes changes that cause one of its parts, its facade in this case, to bulge outward, it would be logical to expect similar results on its other surfaces. Based on the final configuration and the tightness of the joints, it can be inferred that the same effect should have influenced the block's side surfaces as well. However, neighboring blocks restrict their freedom of movement. This limitation should have been compensated for in some way. This means that when the free space between the blocks was filled, the indentations and cavities on the adjoining sides of the blocks should have either disappeared completely or at least been smoothed out. Alternatively, if we consider certain nuances, such as the force or direction of the effect, there should be far fewer indentations and cavities on the sides than on the facade, and even fewer on the back of the block if it remained rough. In reality, we see that the side surfaces still retain their indentations, cavities, and sometimes even more pronounced defects. As a result, the appearance of the side surfaces is almost indistinguishable from that of the facade. This image shows an exposed section of masonry. It clearly reveals the positions of the blocks in the next upper row. What stands out are the large gaps between the rear sides of the blocks. If the blocks placed on top of this row had been plasticized, then their lower surfaces would have developed bulges matching the shapes of these gaps. However, such artifacts are never found on the undersides of blocks. Mysterious technology allows the facade surfaces to swell and enables the material of the side surfaces to fill gaps of any shape in the joints. Yet at the same time, the indentations and cavities on these surfaces remain intact. And the material of the block's lower part, which was supposed to fit perfectly into the seating area with millimeter precision, replicating all the details of its configuration, somehow managed to ignore the large gaps between the rear sides of the blocks. Beak-like protrusions on blocks with sharp or rounded configurations are often cited as evidence of the material being in a plastic state. They give the impression that the material flowed into cracks and voids. However, in reality, this is the result of preparing the seating area for the next block, rather than filling free space with a plastic material. Such protrusions, like all similar joints, do not fit into the theory of thick consistency concrete either. Each of these elements, including the block with the corresponding shape, would have required separate preliminary preparation. If we consider another option, where the blocks forming the seating area were in a softened plastic state, contradictions arise again. The pressure from the block being placed on them would have caused them to deform, resulting in bulging of the facade surfaces. Additionally, the joint gaps would have fully closed, but, as we see, this did not happen. Therefore, this option is also not viable, and the configurations resembling imprints of blocks on joint surfaces cannot be traces of pressing into a soft material. No such pressing occurred. These are precisely prepared seating areas carved into solid material, receiving profiles for the next row of blocks. The shape of the overwhelming majority of blocks seen in the masonry does not align with the concrete method either. In Sacsayhuaman, for example, the exposed sides of the blocks in the upper rows of the battlements have a rough, jagged appearance. The same appearance is seen on the side surfaces of blocks that were never fitted together. It is impossible to assume that this was done intentionally. Such excess material would have to be removed later. The rough backs of the blocks also do not align with the casting method. They were embedded into the platform fill. And if we assume that the backfill played the role of formwork, we must also logically accept that a separate formwork was made for each block. Otherwise, the blocks in the same row would not have had different thicknesses. Moreover, masonry with exposed back surfaces of the blocks does not fit this scheme at all, unless we assume that the backfill was deliberately removed after casting for some reason. The casting method is also inconsistent with the construction of double-row masonry with filler material between the rows. The filler can only be poured after the blocks are in place. If it were added beforehand, shielding panels would be required. but in that case
Но
the
тогда
backs would
тылы
be
были бы
smooth,
ровные,
and the blocks
а сами
themselves would be of
блоки
uniform
одинаковой
thickness.
толщины. Но блоки
However, the
имеют
blocks
разные
vary in
размеры,
size and their
и тылы
backs
у
are
них
rough and
рваные.
irregular.
Аргументом
Another
против
argument
версии
against the
материал был в
softened
мягком
material
состоянии
theory is the
служит и
complete
полное
absence of
отсутствие
torn
рваных
joints.
стыков.
If the
При
material
пластичном
had been
материале
plastic,
избежать этого
avoiding
было
this
бы
would have been
невозможно.
impossible.
Нет ни одного
There is
стыка,
not
где
a single
боковые
joint where
поверхности
the
блоков
side
не
surfaces
были
of the
бы
blocks were
специально
not deliberately
подготовлены.
prepared. They form
Они
receiving
представляют
or
собой
responding
преемные
profiles
или
of the
ответные
joints
профили
created by removing
сочленений,
material.
которые образованы удалением твердого материала. Если бы материал был
If the material
пластичным,
had been plastic,
необходимости
there would have been
подготавливать
no
преемные
need to prepare
профили
receiving
и в скальном
profiles in the rock
основании
foundation.
не возникало бы.
The blocks
Стыковать
could have
можно
been
было бы
joined without
совсем
any
без
preparation of the
подготовки
receiving
преемных
profile,
профилей или с
or with
минимальной
only minimal
предварительной
preliminary work.
подготовкой. Между тем, преемные
However,
профили в
receiving
скальном
profiles in the
основании
rock foundation are a
нередко очень
consistent
сложной
feature.
конфигурации регулярный момент. Если продолжать эту
Following this
логическую
logical
цепочку,
chain,
то
one would
придется
have to
признать,
admit that the
что
receiving
преемные
profiles in the
профили в
rock were
скалах
also
также
cast,
отливали
or that
или
some
какими-то
unknown methods
неизвестными
were used to
способами
achieve the necessary
добивались
softening in
необходимого
those
там
areas.
размягчения.
There are also
Нет
no
также
traces of
никаких следов
formwork,
опалубки,
which would have been
которая была
necessary when
необходима
working
при
with a
работе
flowing
с текучим
material.
материалом.
The idea that
Предположение, что
jute
при
or woven
отливке
mats were used
мегалитических
as
блоков
formwork
Саксуэмана
when casting the
использовали
megalithic blocks of
мешковину или
Sacsayhuaman
циновки,
cannot be
нельзя
taken
воспринимать
seriously.
серьезно.
To cast
Для
massive
отлива
corner
массивных
blocks with
угловых
rounded
блоков с
configurations in the
округлыми
battlements of
конфигурациями
Sacsayhuaman,
потребовались бы
formwork of the
опалубки
appropriate shape
соответствующей
would have been
формы,
required.
и добиться нужного
Achieving the
результата с
necessary
помощью досок,
results using
циновок
wooden
и
planks,
шкур животных
mats, or animal
было бы
hides
совершенно
would have been
невозможно.
completely impossible.
При плотности известняка
Given the density of
2500
limestone
кг
at
на метр,
2,500
мы получим
kilograms
при
per cubic
отливке
meter,
давление порядка
casting would
тонн
create pressure
на
of several
квадратный
tons
метр.
per square meter.
Современную
Modern wooden
опалубку из
formwork panels
дощатых
are
щитов
reinforced with metal
скрепляют
rods,
металлическими
yet they
шпильками,
sometimes fail
но и
under
ее
pressure.
иногда разрывает.
Therefore,
И
the
поэтому вариант
idea of using
использования
weak
слабопрочных
materials
материалов
such as
типа
woven mats
циновок или
or wicker
плетеных
formwork
опалубок
is not even
даже не
worth
заслуживает
discussing.
обсуждения.
Another major issue for the concrete theory is the variety of rock types used in the blocks. For limestone, one might still assume it was ground, fired, and converted into a lime-based mortar. Andesite could theoretically be produced using volcanic ash. But how was granite handled? No alternative filler material is observed in these blocks. Moreover, crushing such hard rocks as granite is far more labor-intensive than grinding limestone. Thus, replacing limestone with granite would require additional justification, since such a transition would hardly have made the block preparation process easier. Exposed fracture surfaces on the blocks, as well as their side surfaces, also demonstrate a uniform structure and a complete absence of fillers. Casting such massive and voluminous masonry elements using only a pure liquid solution would have been virtually impossible. In modern construction, for example, crushed stone is used as a filler. It significantly simplifies the process. Another argument against both the concrete and plasticine theories is the secondary use of blocks. If the inserts between the megaliths were cast during the assembly of 6 stones, why was the casting not done as a single continuous pour? The same applies to the structure in front of the 6 stones. The blocks laid there are undoubtedly of secondary use. It is also certain that they were in a solid state during placement. And yet, the configurations of almost all of them have been altered. They fit together perfectly without the use of concrete or plasticine. The vast range of block sizes and shapes also argues against all theories involving softened material states. Casting a new shape for each block every time would be simply absurd. This would require constantly changing the formwork. Moreover, the changes would have to be made not only in 2D, but throughout the entire volume. Casting standardized forms would have significantly increased productivity and greatly simplified all other stages of masonry construction. Small inserts are also frequently found in the masonry. They were used to fill gaps that could appear in block blanks. They were also used to repair fractures that may have occurred on already placed blocks. In these cases, both the blocks and the inserts were undeniably in a solid state. Otherwise, one would have to assume that the block was cast first, then the insert was cast, and then the next block was cast over them. Another argument supporting the use of natural stone in a solid state is that the limestone blocks of Sacsayhuaman display a wide range of density variations, from loose to fine-grained and dense. Such density variation is a typical natural occurrence in different layers of sedimentary rock. To explain why some blocks in the masonry exhibit a porous foam block-like structure, it is entirely unnecessary to assume that the indigenous builders had the technology to produce aerated concrete. Some surface relief features also argue against the softened material theories. If work on solid surfaces is excluded, then smooth-faced surfaces could have only been achieved by rubbing down the texture left by the formwork after the material had partially set. In that case, characteristic marks would have inevitably remained, grooves left by solid inclusions that ended up on the surface. However, nothing of the sort is found on polygonal blocks. Calcite veins found in the blocks also contradict the theories of softened material. In the case of a concrete variant, their presence would have been highly unlikely. Even in the plasticine variant, they do not align well with the theory. No changes are observed in the areas where the material supposedly softened, where facial surfaces bulged, or where the side surfaces conform to adjacent blocks. In conclusion, it is worth paying attention to another important detail. When working with mortar or plastic materials, it would have been nearly impossible to completely avoid contact with freshly cast block surfaces. In such cases, at least occasionally, one would expect to find imprints of workers' hands and feet or tool marks. There should also be traces left by animals or insects. But no such marks are found, not a single one. And this is natural. They could not have appeared on the solid surfaces of the blocks. To summarize, neither the plasticine theories nor the concrete theories, nor, to the same extent, the mechanical grinding theories, meet the necessary criteria. None of them account for the full range of details observed in polygonal blocks. And none of them find real confirmation. The only explanation that meets these requirements is the preliminary preparation of receiving and responding profiles on irregularly shaped block blanks.